That's
Now
all
we're recording. Start over. Just kidding. Just kidding. Good.
right. So
Oh, my beat.
I posted out on Twitter, and this is just also some stuff that I've kind of gathered up on consuming a lot of APIs, writing a lot of APIs. So what makes a great API? First and foremost, good documentation. Um, I can't talk about how key good documentation is to any API. And I'm not just talking about APIs that you're exposing for public consumption, but I'm also talking about APIs for internal use. It's no matter who's using the API, good documentation is very, very important. And it's just as important as adhering to your contracts and not introducing just breaking changes whenever you want. I think most people who have consumed other people's APIs get into situations where all of a sudden there's a breaking change. A value of a field changes, a field name changes, and now everything comes toppling down. You also want to have consistency in your API, and you want to have predictability. I think those two things kind of go together. The more consistent it is, the more predictable it is. One of my favorite things about working with a good API is it being so consistent that you can guess what a URL is going to be based on what you're trying to get out of it. I think that's a really good mark of an API. Standardization, that kind of plays into the other two previous points. And performance. Performance is very important, especially when you get into microservice architecture. Like whether you're consuming an API or you're writing an API, the performance of your API is going to affect the performance of the application API. So the API needs to be very performant. And you want to be able to provide painless evolution. So one of the things I'll talk about a little later is evolution of APIs. Rather than putting like a hard version like v1 in the URL or doing these like hard forks of an API, being able to evolve and making that painless. So let's take a look at documentation. What makes good documentation? Good documentation is going to clearly explain what you can and can't do. The can do is what you'll commonly see. The can't do is something you don't commonly see, but I think can also be very valuable. Good documentation is going to provide code examples. It's going to provide request response examples. Really good docs will provide JSON schema and an API playground, something that you can get into the documentation and immediately have a tangible experience playing around with that. And another great thing that's optional, but providing a mock API is great. And we'll talk a little bit about that later when I dive into workflows a little bit of where that mock API can become really handy. So contracts. When you provide an API, the documentation and the responses of your API are contract. And just like the rest of your life, upholding contracts are very important. Like you don't want to have 10 different very large applications integrate to your API, and then all of a sudden you start interacting, making changes. Everyone's going to be super mad at you and just leave. So it's very important that you adhere to your contracts. And a hot development tip on the development side of things is build request and response abstractions into your application. The request abstractions, depending on how big your API is and how large your requests can get, that abstraction may or may not be necessary. But I always recommend that you put an abstraction layer in front of your responses. And that's going to be like my number one tip from the development perspective on being able to allowing you to adhere to your contract. It'll help you evolve. It'll help you in your evolution of your API, but it'll also help in situations where you're adding, modifying or adding new database fields, adding new domain concepts, doing a major code refactor, and having that abstraction layer. If you're adding a new database field, you can just update that mapping in your abstraction layer. And I've come into many situations where I'm working on an API and we've got to kind of pivot and add a new domain concept. But now that's totally affected the layout of my database. And I only had to update a couple lines of code to keep my API contract up to snuff and then be able to do whatever I need to do inside of the application. So specs, a real important part of building an API is going to be using specs. So not only is a spec going to do a lot of work for you, but it's going to be able to provide a lot of tools for you to help uphold your contract and provide an optimal integration experience for any developers, who are going to be using your API. So look at how much Stripe has dominated the marketplace by coming to market with something that is super easy to integrate to and has a lot of good tooling. And behind the scenes, they're probably using a lot of specs to help them with that. So what are some of the specs that I'm talking about? On the service model side of things, we're going to have OpenAPI, formerly known as Swagger. And on the data modeling side of things, we have JSON schema. And typically, you'll want to use a combination of the two. So for an example, OpenAPI, you'll want to use for laying out your endpoints and also kind of mapping your status codes and kind of saying, this is kind of the schema or the data object that you'll get back for a 500 error, or a created, like a 201 or a 200 success. This kind of maps out what those requests and responses look like. But then you'll use JSON schema to actually, map out what those responses and what that data is actually going to look like. And then you'll also use JSON schema to be able to provide like a mapping for validation to go along with that API. Something that you could also add into the mix is JSON hyperschema. So that'll kind of add in a layer of functionality into hyperschema clients, but you're going to kind of have some overlap there in between JSON schema and your open API, because JSON hyperschema does get into mapping requests and kind of laying out that whole network layer along with it. But if you're going to want to support, if you're doing like hypermedia style APIs, then adding a hyperschema client, like adding hyperschema support to be able to support hyperschema clients is, I think, like a really good idea. So some of the benefits of being able to, providing these schemas is you're going to get documentation generation. So you can look at something like Redoc or Apiary by providing, Open API or using API Blueprint. You now enable a lot of tooling to just automatically generate pretty gorgeous documentation for you. It's going to get code sample generation. You can use these specs to generate SDKs in many different languages. And you'll get client-server validation, which I'm sure we'll talk about in a little bit too. But you can also use these schemas to do contract tests inside of your code base. So there's not, I don't think there's a great library for PHP, but I think that might be on a roadmap for something that I want to build. But Thoughtbot has put together a really great library for using your schemas as contract tests inside of your Rails applications. And you'll also be able to use some of this tooling and your specs to generate mock servers. So here's what an example of a JSON schema looks like. You'll notice that it's kind of got some object titling, and then it dives into the properties, and then it's going to give you like the different types of each of those properties, whether they're a string or an integer, a brief description of it. And then if you look at the age property, you'll also see a property of minimum. And that's part of some of the properties, the metadata that you can add to each property of your schema for validation purposes. And same thing with the required property. You can pass an array of all the things that are required. And this all helps in that tooling generation, as well as that client server validation that you can add in place. And this is basically shows the difference between JSON schema and JSON hyperschema. And the real big difference is you'll notice that additional network layer that I talked about towards the bottom, where it provides like the base URL and then gives you some hypermedia links, but then gives them in a templated fashion so that, like a hyperschema client can parse those and automatically generate all the URLs for all the different hypermedia links. And that's where you can kind of see some of that overlap between what OpenAPI provides and what JSON hyperschema provides as well. I didn't have any examples of what OpenAPI looks like because it gets pretty lengthy. And you can just kind of go to the OpenAPI documentation, and they have a whole playground for playing around with it. But it was just a lot of content to throw into a slide. So standardizing your API. It's going to make your API predictable. It's going to make it easier to reason about in discussions, and it's going to help bring a lot of consistency. So one of the reasons why I like Laravel, and I think a lot of people inside the Laravel community really like Laravel, is it's highly opinionated. And that kind of takes some of the overhead about like thinking about some of your decisions and discussing them, too in depth. So if you've got a team, you're already going to be having a lot of inner discussion on how you're going to architect things, the way things are going to work, but bringing in this layer of standardization, using specs and using some of the other things I'm about to talk about, kind of brings some clarity to those discussions where you're not going to be talking about a lot of the standardized stuff. So looking at standard media types, Siren, HAL, JSON API, use what makes sense to you and your team. I don't think it really matters which one you pick, just pick one. It'll make your life so much easier. And here's an example of Siren. A good friend of mine, Kevin Swiber, he's the author of this spec. And this spec was primarily used, at least for like what the reason why he came up with it, was in the IoT realm. So this was kind of designed specifically looking at, IoT and server-to-server communication. And this is kind of an example of what HAL looks like. You'll notice they're really pretty similar, just some slight syntax differences. And then JSON API, which I think is probably the most well-known and one of the more popular ones. And then you'll kind of you can take a look at this. So we also have standard and paradigms. REST with HADIOS support, and the REST-ish paradigm with non-HADIOS, and then you'll also have like an RPC. And so this is kind of an example of what a HADIOS response looks like. So HADIOS stands for Hypermedia as the engine of application state, and it means that hypertext should be used to find your way through the API. So one of the things that I really like about the HADIOS paradigm is it kind of is like self-documenting, and you can build a lot of tooling that'll automatically crawl the links. And based on the relationship property that you can see down towards the bottom of this example, you can kind of spin up different actions. So if we're looking at something kind of like the Siren spec, and you could have some sort of response back on all the different actions that you can take on a device. So if you caught Matt Stauffer's Laracon Online talk, where he had a light that was changing different colors, you could have a bunch of different links in this array that would turn it specific colors. And so based on that rel, you could populate all the actions for the buttons. So you could automatically list out all the different colors. And let's say the response changes on the next one, the UI will just kind of spit out all those buttons. So it can be really powerful. So then you also have some standard implementations, and that's where you'll see GraphQL, gRPC, and JSON RPC. And then while we're on the topic of standards, let's talk about authentication. Don't invent your own authentication paradigm. Use some sort of standard that's out there, whether it's basic auth or OAuth or a long life token. You'd want to put that long life token under the authorization header. But don't invent your own authentication paradigm. Use something that's already out there, that's proven, that's well known. Personally, I'd say stick with either OAuth or some sort of like static long life token. And if you want to get up and running fast, Auth0 is fantastic. I run a local JavaScript meetup, and we had one of their developers come out and give a talk, and I was blown away with how fast and easy it was to integrate into a Vue.js SPA. And afterwards, I did a little digging into like what it would take to integrate it into Laravel, and it's super painless and very secure. If you're looking to get up and running really quick, I think that's something that you should definitely look at. So another really important factor of your API was performance. And to add some really easy performance wins, you're going to want to do a lot of planning and collaborating with your team, and as well as potential consumers or people who are already consuming it, and research the needs, like the payload needs. Research what the data you need to return. And the reason why this is really important is that you can optimize your queries inside of your application. The more research you do, the more things you can do to, avoid like N+1. A big problem that I see in a lot of APIs is if you're doing like query parameter includes, like if you're going to get an author and get all of the articles that the author has created, and then you want to maybe get some properties on the article too, real quick there, you're going to run into a lot of N+1s. So kind of planning out stuff you want to do by default or stuff that you want to leave optional for the consumer. A lot of prep and planning can help your code base be a lot cleaner, but then also really optimize those queries. HTTP2 support. It's pretty standardized across most major browsers now, and it's pretty easy to integrate into Nginx and a lot of other web servers. If you're using Caddy, it supports HTTP2 out of the box. But that's going to really help provide a lot of performance if an API is going to be making a lot of, over-the-wire requests. And if you're going to do like a GraphQL, if you don't want to do GraphQL and you want to stay with something like a little more REST, HTTP2 can help speed up a lot of like gathering a lot of nested resources. gzip, this can help a ton, especially if you're doing rather large JSON payloads. Adding the accept encoding header of gzip can really help a lot. And then for the love of all things holy, please send cache headers. Otherwise, developers are going to have to make best guesses on how long to cache things, or maybe they won't even cache things and just fetch new data all the time. If you send cache headers, you can kind of set that expectation of, hey, you should cache this, and this is how long, we're the domain experts, we're providing the API, this is how long you should probably cache this data for. So definitely take the time and send cache headers along with your responses. So API evolution. This is something I touched on a little bit earlier, but and something that I'm gaining a lot of passion about. I recently authored a rather large API for International Band Card, and there's really not much versioning that I put in place because I really wanted this API to kind of naturally evolve. And API evolution is the concept of striving to maintain the I, which is interface, and API. So the request and response body, query parameters, general functionality, only breaking when it's absolutely necessary. So let's say you need to add some new properties. Not a big deal, just add them. The other side of that, though, is how are you going to handle depreciations? If you're not going to have some big fork in your URL, things are going to depreciate over time. And there's a couple different ways you can handle things depending on the type of depreciation you're going to do. Let's say you want to depreciate an endpoint. Send the sunset header. If you're authoring SDKs, which I really recommend authoring SDKs, whether either internal or external, and having that schema can help you automatically generate some of these SDKs. The SDK, when you make a request to a depreciated endpoint that has the sunset header, it can raise a warning. You can add it to your logging to let you know, hey, this endpoint's going away. You can also add a link header to tell them where to go to find out what's replacing it or why it's going away or what to use it instead. You could send them a link to your documentation. You can send them a link to the open API spec and give them like some JSON schema that the new endpoint should adhere to. Then we have property deprecation. And these are things you can do inside of your documentation. Open API has support for depreciated properties. JSON schema, it's in progress. Depreciated properties are in progress right now. And just as the endpoint, endpoint depreciation with an SDK, the SDKs can raise a warning on access. So there's a couple different ways you can do this. In PHP, you can kind of look at a class like a getter method on there, and add a little layer of abstraction in there that says, hey, you're getting you're accessing a property that's been depreciated. And you could actually, inside of your code base, grab the JSON schema or have some sort of cached version of the open API, and then automatically be able to issue those warnings in the SDK. Another thing about using JSON schema in the SDKs is you can have the schemas be served up on the server automatically. So the SDK, like when it fetches the payload from that endpoint, it can also fetch the schema and then automatically, have that like server to client side SDK interaction. So validation changes. This is something that's not often thought of, but is definitely a problem. Let's say you have a field that used to be able to take 50 characters, but for some domain reason, you need to only take 20 now. Like I was just mentioning, like the SDK can use server-side schema rather than hard coding inside of the SDK. And then the SDK automatically picks up those changes without having, issue a new version of the SDK. It's just done on the fly. So here's some key takeaways. Provide good documentation, use platform and data specs, use a standardized format spec, and really just standardize as much as it makes sense to for your different domain, for your application. Be predictable and consistent, make it performant, provide SDKs, and like I said, a lot of this tooling can help automatically generate SDKs for almost any language you need. And use existing standards. Try not to invent your own paradigms as much as possible. A lot of these things are getting pretty, a lot of these standards are getting pretty wide adoption, and that'll help a lot from the integration experience. Let's talk a little bit earlier about how some of this can help your development workflow. From top to bottom here is a pretty ideal workflow. You're going to document, you're going to sit down with your whole team, and you're going to document the resource and platform spec first. It's like the first thing you're going to do is build out the documentation, plan out the responses, and not saying you have to sit down and do the whole API end to end, but if you're doing a sprint-based type workflow, then this is part of your sprint planning. You're just going to kind of plan out whatever parts of the API you're going to work on for the next couple weeks, and then plan accordingly, do that research, and build that spec out. You can even work a sprint ahead, so you've got some buffer time there. Doing that and pairing that with a mock API, both the front end and the back end teams can build in parallel. So rather than the front end team being held up by the back end team or some sort of horrible conundrum like that, everybody can work in parallel. The back end team can be using the spec to do contract tests to make sure that they're adhering to that contract. And the front-end team can use the SDKs and the mock implementation to build out the UI and kind of test things out there. Evolve your API using the spec to help you maintain the contract. Use the spec to build SDKs that can alert to appreciations. And then you can use those specs in a CI environment to build automated Postman collections, test the documentation, and make sure the actual implementation matches, the documentation, and everything's, pretty seamless. So some of my go-to resources are pretty much all published by Phil Sturgeon. He's a good friend of mine. He wrote the Building APIs You Won't Hate book. That was very influential in a lot of the viewpoints that I have on APIs. The blog is absolutely fantastic. It's constantly being updated. A lot of the content that I talked about in this talk, Phil really goes in depth on a lot of these topics, and you can learn all about them and really dive into the grit of how to implement them. He's got a new book that's in progress right now, Surviving Other People's APIs. I think he's about a quarter to half the way through it. And then there's an excellent Slack community for that whole APIs You Won't Hate community. So you can go in there, drop in, ask questions. It's a fantastic resource. So that's all I've got for the presentation. I'm definitely open to Q&A or anything you guys kind of want to talk about as far as APIs go.
Sweet. Thank you, TJ.
Yeah, for sure. Thank you.
Versioning.
Mm-hmm.
How do you deal with that? Or what's your take on versioning an API?
So I definitely have gotten out of the habit of doing the like hard forks in the URL where you'll see like /v1 or /v2 or something like that. And I've basically gotten rid of most versioning in my APIs and just have really relied on the process of evolution. So, but like I said, if I have to like add new properties or depreciate old ones, that's all kind of handled through the JSON schema and the open API spec and SDKs that I can provide along with the platform. However, I have added in a little bit of versioning just as a failsafe. I'm using kind of, I don't know if you're familiar with Stripe's versioning paradigm, but you can send along like a date, like a 2018 hyphen 05 hyphen 10 for both the request and the response inside of the header field. And then you can kind of in your code base sniff that out and migrate in between requests and responses. But I haven't had to do that yet. I've been able to just rely on adding new fields or depreciating old ones and coming up with alternatives. If you plan carefully, you can avoid it.
Okay, thanks.
That's interesting. The last project I was on, towards the end of it, the guys that I've talked to about that project, they got like really version happy. Like everything that changed was a new version, and the stance was kind of like, well, it doesn't hurt, and this allows us to ship in parallel. So there was just a lot of that. I don't know what I'm saying, but I guess I would love to. I don't have any real world examples to test the evolution approach, but I don't know.
Yeah, so the evolution approach definitely takes a lot more like careful planning. Doing like hard forks in your URL or passing a lot of like version stuff around, you can do less planning because you can just do hard forking. But I also want to provide like a really clean experience, and the versioning, the harder versioning, I think works better with like an RPC, kind of based API, which you see pretty commonly in microservices because what you're doing is kind of like a remote procedure call. So like you could have like different versions of that function that take different input and have different output. But even there, I think you can do some planning to kind of avoid that in an evolutionary sense. But I think it's a lot harder to do with an RPC type API than it is to do something that's like REST or REST-ish.
Gotcha.
But it can create some confusion on the consumer's end with all the different versions. But I think it also really bloats and adds a lot of complication to your code base because now you've got to support, like, let's say you've moved real fast and made tons of breaking changes. Now you've got to support 8 different versions of essentially the same domain concept. That's a lot to try to keep up with.
Yeah, for sure. What's your workflow with working with OpenAPI or Swagger? Like when I usually work in a text file and then copy and paste the whole thing into their online editor to validate it and stuff. It's just a long back and forth.
Yeah, so I'll depending on like what editor you use, there's some tooling kind of built into some of the larger editors. So like Atom I know has support for I think OpenAPI 2 and API Blueprint, and VS Code I think is in the same boat where you can where it will not only validate the to the spec, but you can also get like a preview of it rendered over in like a split pane type area. But I'll also just dive in and use their editors online. So I'll use like the Swagger editor for OpenAPI. If I'm working with API Blueprint, I'll just work inside of the API editor, and I just kind of like work in the browser for those. But I think if you really wanted to work locally, I'd probably look at either Atom or VS Code and some of the integrations there.
Can I ask a question about these enterprise platforms like Apigee? Their
Yeah.
basic. So can you give me your basic philosophy around working with large organizations where there's MuleSoft, there's Apogee. Tell me about what your philosophy is when you have a client and you want to be able to make these calls where there's either versions or restrictions, and so basically finding the specific API for your application. So tell me how you manage these large enterprise platforms.
Well, so at work, we do payment processing. So all of our infrastructure is hosted in AWS. And I've just kind of built out all the different pieces of the puzzle there. So I've got like an authorization service, and we've got like an API gateway that was provided by AWS. And we kind of just like piecemealed our own infrastructure. Apogee is great. A friend of mine worked there for quite a while. MuleSoft is also like really pretty good. I don't have any direct experience working with either of those.
We
Build our
lost.
own stuff.
Wait, TJ, can you repeat the last two sentences?
Yeah, I think I dropped there for a second. Yeah, so I don't have any like direct experience with either of those platforms. I've just kind of rolled our own infrastructure and kind of built everything in there.
Yeah, where I see it is like organizations, like large organizations, are using those platforms because it's overwhelming the amount of methods to. And again, this one-to-one approach where we're going to this microservice model. Organizations have overwhelming it's going to be very difficult, other than using these platforms like Apogee and MuleSoft. And so, what is your strategy to publish? Because for you to expose your API platform to MuleSoft, it gives you a little bit of extensibility to those platforms, right?
Yeah, yep. There's Apogee, MuleSoft, and there's another I can't remember the name of it. There's another like API gateway that works pretty well. I think like I said, I don't have any direct experience with them, but I think they're really good choices, and it comes down to just doing the research and finding out what's going to work best for you. Microservices are really tough. It gets really complicated. There's lots and lots of moving parts, but there's also a lot of tooling and platforms that are coming out to help you with that, like Apogee, like MuleSoft. AWS is building in a lot of tooling to kind of help you with that process as well.
Okay.
Yeah, I think it can make a lot of sense. So, like I've not had a need for them, but I know people who have, and it's been it's helped them do a lot of management and kind of keep the overhead at a little bit more of a sane level.
Yeah, if I can mention something from an enterprise perspective, you come from an organization, billion-dollar corporation, there is vast amounts of APIs, and how do you categorize them all? And I just wanted to see what you were trying to do, and your philosophy and how to attack that massive undertaking, if that is something you have to deal with.
Yeah, I haven't done anything at a like an enterprise, like a really large enterprise scale. The products that I've worked on with APIs have been really focused, and I've been able to handle it with just a couple applications and like 2 or 3 sets of docs, like nothing too crazy. But I know there's organizations that have 40 or 50 APIs, and each of those have like 60 endpoints, and it can definitely be a nightmare to deal with. So pulling in these platform management solutions, I think it's a great idea.
Questions?
Cool.
We've already talked about this at length, but I don't know, it might be fun worth at least bringing up. When one of the clients I was working for, we were doing what you described with the workflow, parallel front end and back end development. Like we had this feature to do. It was this huge feature, and we're like, oh, well, we're all microservice out, so it'll be fine. I'll go on the front end, you go on the back end, and then we'll meet at the end, plug them together, and everything will be great, which is, of course, not the case. But so I hit up TJ and he pointed me towards Apiary, which is a service that, so like half the words you said in there, TJ, are kind of over my head, just because I'm not like in the API world. So a lot of the words I'm not up on. But Apiary is like a service that accepts, is it JSON or API Blueprint? Is that the spec?
Yeah, so like Apiary is like a documentation platform for APIs. I'm using them currently. I'll add the caveat that they were recently, or like I think within the last like year or so, bought out by Oracle, and we've had a really rough time with the like the backend administration stuff of like billing and account management with Oracle. But Apiary as a platform has been really pretty good. So what you can do is it's primarily built to use API Blueprint, which is a similar purpose but like different spec than OpenAPI. But I think it also supports like OpenAPI 2, and the current version is OpenAPI 3. So depending on like what you want to work with, you might run into some issues there. But you can write your spec in like OpenAPI, and it'll automatically generate some pretty nice looking documentation for you. And it'll automatically give you like a mock API it makes it pretty easy to set up like Dread, which is another tool to kind of like help validate your API. So let's see, this is some documentation that for an API that I've worked on, and this was all built with OpenAPI or with API Blueprint. And you can kind of build out all these pieces of the documentation. It looks really pretty nice. When you get down into the requests, it will give you like a full breakdown of the request, the body that you need to send, like the responses that you'd get back. You can take a look at the JSON schema that it provides. It will also give you different implementations to look against the mock server. So if you want to use curl or Java or Node, it'll kind of give you like a really, really easy way to copy and paste and use their mock server. Right now, I don't have this hooked up to our production server, but you could have it hooked up to a production server and like a sandbox area, and you can try it out right from there. So you can either copy and paste that example, or you can call that resource just inside of here. One of the things that the mock API doesn't provide that I know that you had a problem with, Caleb, was it doesn't do validation, which can lead to some issues when you kind of try to marry up the front end and back end parallel work. Is validation just totally being thrown off? But that's where building the SDKs that actually do the validation based on the JSON schema, that's where that can really help quite a bit.
Yeah, nice. Yeah, so it totally came handy for us. So you write this out in JSON Blueprint, you get this insanely beautiful documentation, and then on the front end, I developed with a mock endpoint. I just like popped it in as if like I could literally copy and paste out the real one when the time came. And then on the back end, they used the endpoint and to use mechanical keyword. They used the endpoint, and then Dread basically like would compare the mock endpoint to the endpoint they're building and tell them when they're all in sync. So it's kind of this all-in-one package that we're both able to work on the feature in parallel into the endpoint when we just drop out the mock, connect the dots, and for the most part it worked. The only problem with it was honestly just humans not paying attention to the blueprint. That was the only actual issue, was people not abiding by the spec and introducing new things, or not changing the spec when they change the code.
Yeah, that's where developing the JSON schema and then using that to build contract tests right inside your application can make it super, super easy. Let's see. It was, yeah, this is a Ruby implementation, but basically you can like declare your JSON schema, and then inside of your test, you can kind of like pass in where like your schemas live, and then have it assert against that JSON schema. So that kind of helps that issue of that divergence of like, hey, here's the contract, and while the front end is abiding to the schema, maybe by an SDK or using the mock endpoint, the front end is going to be kind of in one place, but then the back end kind of changes some property key names or changes like some value type that comes through. But actually taking a look at the JSON schema and doing contract tests in the API's code base against that schema kind of prevents that divergence.
Nice.
So this is what basically like the back end of API Blueprint looks like. So this is like the API Blueprint that you write here. API Blueprint doesn't support like adding JSON schema into the mix here, whereas with like Open API, you can actually reference like remote JSON schemas. And that's where you can kind of get that blend of like using Open API for the platform and then using JSON schema for the like data spec and kind of combining the two together. It's not really something you can do inside of Apiary though. But you can map out like your request and your different attributes for the request, and then map out the JSON schema for your results. And it'll automatically generate all of this. So you get like the different headings, everything's linkable. And then based on the request that you add here and the response that you add here, it automatically builds out like the JSON schema, uses like the example properties to build up like what this would look like. And then this example is what actually gets returned by the mock API. And there's all sorts of tools to like be built on this, like Swagger, not Swagger, well, it's like Swagger Open API. They've got like their own documentation generator. I think there's like Slate does a pretty good job of like Open API documentation. And then my favorite as of late is a project called Redoc. And a lot of these other documentation generators are using older versions of the Open API spec or using older versions of the JSON like JSON schema spec. Like you'll see here, it's using like Open API v2. They're working on getting a lot of Open API v3 support in this documentation. So this generator I have found to be the most up to date as far as the different JSON schema drafts and the Open API spec. So if you wanted to like look at like documentation generation, I would highly recommend using Redoc.
Cool.
Some of the things that you don't get using Redoc that you do get with like Apiary is like the mock API, but there's a lot of other tooling that can kind of like spin that up and you can get that mock API elsewhere.
Cool. Any questions, thoughts? Anybody?
No.
Sweet. Well,
Awesome.
Yeah, appreciate it.
Thank you.
Yeah, thanks for having me, guys.
Alrighty, we will we'll get this online at some point soon.
Sweet.
All right. Thank you, TJ.
Awesome. Thanks, guys.
All right,
Thank
peace.
you.